Welcome and hello. This is a video exercise in HEC ResSim, and in this exercise, I'm going to be covering diversions. All right, so what I have on the screen here is a brand new instance of HEC ResSim. We're going to sketch out a network and add some diversions and then run a simulation and see how that works. All right, so let's go ahead and get started. I'm going to go File, New Watershed, and then give the watershed a name. I'm going to call mine Video 22, select the location. It will be in this directory. My units will be in English, and then the time zone will be Pacific. That doesn't really matter for this exercise, but got to select something, so going with it. Okay, I'm going to go ahead and zoom in a little bit now, and then select my stream alignment tool here. Hold down the control button, and then single left click. Continue holding down control, and I'm going to click a few more times, and then let go of control before your last click, and give that stream a name. All right, next I'm going to add a computation point at the upstream end. I'm just going to hold down Control button and single left click, and I'll call it CP1. Next, I'm going to add a few diversions. I know it's called ResSim, but this exercise will actually not have any reservoirs. I wanted to just focus on diversions only and sort of isolate the topic of learning to reduce any extra ideas or things that we don't need to think about right now. But you can imagine an upstream reservoir or downstream reservoir, whatever. Diversion tool, I'm going to go ahead and hold down control and then a single left click. And then this is going to be an unconnected diversion, which means it just flows out of the network. So I'm just going to go out of here and then click. I'm going to call this diversion to city A. Okay. And then that's going to create a CP2 computation point right there at the stream alignment. So I'll continue that a couple more times. My diversion tool is still selected. I'll just hold down control and then over here, I'll call that diversion to city B. And one more time, diversion to city C. All right. I'm going to add one more computation point at the bottom and call this CP5. So it's the downstream most computation point. Next, I'm going to go up to Watershed and click Configuration Editor and create a configuration. So configuration, new, config 1, and then the time step will just say 1 hour. And then I'll click Apply and OK. All right. What I want to do now is save this watershed, and that's good. And let's head over to that Reservoir Network module. So that's what I'm selecting up here in the top left. Now I need to create a network, call it Network 1. That will be based on the configuration that we just created, and then click New. All right, so I have my diversions popped into place, my junctions, CP1, 2, 3, 4, and 5, going from upstream to downstream. I'm going to connect them by clicking this Reach tool in the left Tools menu, hold down Control, and then click, and then let go of Control, and then click again. I'm just going to accept the default name here that they suggest, and then continue that building the reaches from one junction to the next all the way to the bottom. All right, that looks good. Next, we want to add some inflow to CP1, and then it's going to flow down to CP5. And then I also need to edit some data with regard to the diversions. So let's do the inflow first. I'll click the junction tool, right click, edit junction properties. Now I'm going to select this local flow tab, and then on the first line, I'm going to say inflow at CP1, and then multiply factor will just be 1. Okay, or apply, and then okay. So that just identifies CP1 having an inflow, but we still need to create the actual data, the actual flow rates for each time period. So let's do that now. I'm going to go ahead and go Tools, HEC DSS View, and then File, New. I'm going to create a .dss file. And the default directory, it starts me in my watershed directory. That's fine. I'll just create it here. It'll be called time series data.dss create. Okay, it's been created, represented by this file path up here, our file name. And then let's go ahead and create it. So manual time series. What I'm going to do is a month-long simulation during the month of July 2024. So let me just add some path name parts here. project, location within the project, flow. I'm just going to call this 0K to 4K. So you'll see what that looks like in just a moment. July 2024. Hourly time step is what I'll use. So we'll go start with the first hour. The units will be in CFS, and then instantaneous value is fine. All right, so I'm going to Control V to paste. It didn't work. There we go. All right, so I pasted in some numbers, and what you're seeing is a linear increase from 0 up to about 3,600. Let me just save that, and then we'll look at the plot. So I'm going to click this record, click on the plot, and here we have what I described. Each hour increases a certain amount, but it doesn't start right away. It starts into the first day. All right, so that's cool. Let's go ahead and put that away from now, and then go ahead and assign that later when we create alternatives. All right, so here are our diversions. Let's go ahead and edit diversion. I can also enter this diversion editor by going edit and then diversions here. It works the same way. And then we can select the diversion we want to edit at the top here from this dropdown. So if I want to select diversion A, I select that, and then I say what the diversion should be. All right, what I have on the screen here is an Excel window over to the right. And what I want to do is basically have three different diversion cities and then downstream flow and then the reservoir release. So pretend there's a reservoir up at CP1 and it's releasing flow, or there's no reservoir. It doesn't matter. This is the flow rate along the left-hand side. What this first row means is if there's no flow from the reservoir, then there's no flow to diversion city A, diversion city B, diversion city C, or downstream flow. Now, downstream flow refers to the downstream most junction that's downstream past all of the diversions at CP5 here. This diagram here, it basically has one row per inflection point. If you're familiar with ResSim's explicit system storage balance method. If you're not, that's fine. I'll explain what it means. But basically, it talks about how each new unit of water, how it should be allocated. In this case, to diversions, as opposed to water coming from the storage of different reservoirs. So what I'm going to say here in the next example is the first 500 CFS of water, 500 units, all goes to city C, which means if there's only 300 or 400 CFS, it needs to pass by the city A diversion, then the city B diversion, and it all goes to city C. And then none of it goes downstream. Okay, once we have more than 500 CFS, like say we had 800 CFS, then it gets equally divided between the diversions of city A, B, and C. So they each get 100, 100, and 600. If there's a total of 1100 CFS, that would be an additional 200 for each of those three diversions. And again, the downstream flow gets nothing. Now, up to 1600, the next 500 CFS goes all to the diversion to city B. Once that's up to 700, the next 500 CFS up to 2100 all goes to city A. At this point, the diversion to city A, B, and C are all the same at 700 with a total flow of 2100. Then they all fill up to 1000 CFS. And then after they all have 1000 CFS, the remaining flow goes to that downstream flow, down CP5. As I'm doing the diversion to city A, for instance, I want it to depend on the flow rate. So it's going to be a function of flow. And then these two columns here will basically be these two columns here. So as the reservoir release increases, or as the flow through that stream increases, so does the diversion to city A, B, and C. So let me just paste that in. I'll go copy and then paste. Okay, and then the little thumbnail sketch pops up on the side. That's cool. And then I'll click apply. I'm going to do the same thing with city B here. So I'm going to select function of flow. Then I'm pasting in the numbers, apply, and then city C, function of flow, and then pasting. All right, that looks good. And apply. All right, so we have our diversions, our inflow. We need to create an alternative and then run the simulation. So let's go ahead and click OK to that. Alternative, edit. And then we are going to go alternative new. I'll call this alt 1. OK. It's going to be an hourly time step. The operation, if there's no reservoir, Okay, so the look back period, it's going to start at a 0 diversion for all three of the diversions because that time series data set we created starts at a 0 flow. And then the time series, this is for CP1 here. So I'll select this record and then click the select DSS path button and then navigate to my time series data.dss file, select that record for the time series, and then click set path. That assigned the path there to CP1 in my alternative. So I'm good there. And then alternative, save, close, and let's go ahead and save the network. All right. Let's go ahead and select the simulation module. We're almost there. Simulation, new, simulation 1. And then we'll select July 2024. We'll start on the second hour so that the look back period can start on the first hour. The end date will be the last date of the month, the last hour. And then I'll select my alternative 1 here down in the bottom and click OK. So the network now appears in the main display. And I think we're ready to go. So I'm going to click compute all and it ran and then close. Now to analyze the results, I'm just going to go up to DSS view. Okay, so I'm going to use the filter and just say flow. And I want to get all the records. So CP1, diversion to city A, B, and C, and then CP5. Okay, so I'll click the plot and something's funny. Let me check the diversion data one more time. Oh. Okay, I goofed up. What I need to do is change this flow location. It was looking at the downstream data, which doesn't really make a lot of sense. So flow location is based on CP1, which is the upstream data location. All right, so let me save that for div for that for B, and then CP1. That's the diversion of city B, and then okay. All right. I skipped a step. And okay. And then okay. And then compute. All right, let's see what our data looks like now. Tools, HEC DSS view. I'm gonna just filter by flow. I want to see CP1, diversion of city A, B, and C, and then CP5, and then plot. All right, cool. This is what I was expecting to see. So what we have here in green is the total inflow. We've seen this before. It just ramps up from 0 all the way up to like 3,600 approximately. And then down below that, we have our diversion to, in blue here, light blue, this is the diversion to city C, and it gets the first 500 CFS. In fact, let me zoom in on the lower half here. All right, yeah, so diversion to city C gets the first 500 CFS. After that, it shares the next 600 CFS with all three diversions equally, which goes up another 200 CFS to 700. And then it waits at 700 until the other two diversions are both flowing 700, which isn't until like a total flow of 2100. And then again, it shares the next, 900 CFS until all three diversions are flowing at 1000 CFS. So this slope is the same as this slope. And we look at how about the diversion to city B, which is the yellow line here. It goes up to 200 and then it increases to 700 and then it waits until all are 700 and then follows the same curve. And then here is the diversion to city A in blue, which is similar as well. And then the downstream flow here is last priority and it goes up to about 600 CFS, but it has to wait at least until the flow exceeds 3000 CFS in the system before it starts getting any flow in that downstream reach. All right, that's cool. So we could do some analysis on this plot alone. So for instance, if we wanted to see if the total flow was 1500 CFS, how is that water delegated? How is that water divvied up to the different cities? So I could go tabulate. And then here is my total flow here. So I could just scroll down to 1500. Here it is. So it would be a breakdown of 200 to city A, 600 to city B, and 700 to city C. So that's basically just the plot, but in numbers. So you can do an analysis that way. Or what we could do is change part of the simulation. So for instance, maybe there was some policy that said like the first 400 CFS must go to CP5, the downstream reach, and bypass all the diversions. So if we did that, the red line would be on this slope here, and then it would go over And then all the other plots would just shift over to the right an equal amount of 4,000 CFS, which is what, probably 3 or 4 days. Let's go ahead and do that. We'll call it a trial. So this is the original, the base alternative, and then we'll do one trial where we're giving that downstream flow requirement a priority over all the cities. All right, so I'm going to close this. I'm going to close that. I'm going to right click on alternative one and say new trial. And then I'm just going to call this trial 400 CFS downstream priority. Okay. And then I'll right click, edit run. And then all I'm going to do is change the diversions. I'll have to just change these three tables. Okay, so here's my Excel and I modified it just a little bit. So now what I have is the first 0 is the same. And then the next row down is now 400. So I've inserted this one row here and I got still 0 flow to each of the cities, but the first 400 goes to the downstream flow. The numbers from the previous table are now pasted in here, are these ones, and I added 400 to them. So what used to be 3,000 is now 3,400, and that's when all the diversions are flowing at 1,000 CFS. And it's at that point that the downstream flow would increase from 400 up to, whatever excess there is beyond the 3,400 CFS. All right, so I'm going to go ahead and paste in the new numbers that are associated with this. So this would be my diversion to city A now. I'm going to copy that to my clipboard. And then let's see, here's A. So I'm just going to paste and then hit apply. And then select diversion to city B and then paste. Okay, I just went over to Excel, got that. And then apply. And then diversion to city C. Okay, I just copied over the diversion to city C data on my clipboard, pasted it in, and apply. All right, so that should work. Let's see what happens. Okay, and then we're going to compute. All right, so let's go ahead and take a look at the data. Once again, I'll go to flow, and then I will filter, I'll say alternative one. Okay, that's fine. CP1, city A, B, C, CP5. And here's my plot. Again, we have the green line, that's the same. And then this is interesting. We have the downstream flow as we would expect it. The first 400 CFS go to the downstream flow. Let me zoom in here. And then it levels out at 400 until all three of the diversions, the city diversions, are up to 1,000. And then that's when the downstream flow increases. What you're seeing in the other plots for the cities A and B and C is similar to what we saw previously with the original simulation. And yeah, that's cool. We could do more analysis on this as well. We could look at maybe the flow rate to city C, comparing the two alternatives. In fact, that might be a little bit easier if we just click both of these on and then right click here and then plot. So yeah, what we see here is the plot and it's just offset by what, 4,400 CFS. So the green line here would be without that 400 CFS priority to the downstream, and then red would be after 400 CFS priority to the downstream. All right, well, this was just an example of using diversions in HEC ResSim.